Hello friends, welcome back to my channel Engineering Mathematics djganit. From this lecture onwards, we are going to discuss about permutations and combinations. Permutations and combinations are nothing but counting techniques for certain type of processes. So first we will concentrate on permutations. We will understand what is permutation and how to count the permutations, and then we will go for combinations. So as we have understood from our school level that if we are interested in the arrangement of objects, permutations and combinations are nothing but arrangements of given objects. So to count the arrangement of objects, we are using this concept of permutations and combinations. For example, suppose we have three objects denoted by say A, B and C, and we are interested that how many arrangements of these three objects are possible. Now whenever we are doing the arrangement, we have two cases, that order is important and order is not important. So there are two types of arrangements. One is ordered arrangement, another is unordered arrangement. If order is important, then we have different number of arrangements. If order is not important, then we have different number of arrangements. For example, if we consider order important for the arrangement of these three objects, then we can list out different arrangements. Suppose I fix first object A and I vary second and third object as B and C and C and B. Then because order is important, I will consider these two arrangements as different. Similarly, I can have BAC, BCA. These are also considered as different arrangements because order matters here. Similarly, I can have CAB and CBA. So if order is important, then we can see I have 1, 2, 3, 4, 5 and 6 arrangements of these three objects. There are 6 arrangements of three objects taken all at a time, and here we consider the assumption that repetition of object is not allowed. So these are the arrangements in which we are not repeating the objects. So we can say that these are the arrangements without repetitions. No repetition of object is allowed. That is, we are not considering AAA as an arrangement. Here A is repeated 3 times. So if we are writing the arrangements in which order is important and there is no repetition of objects allowed, then those type of arrangement is called permutation. Permutation is an ordered arrangement. Permutation means arrangement in which order is important and we are not considering repetitions. So there are 1, 2, 3, 4, 5 and 6 ordered arrangements of these three objects without repetitions. So we can say that there are 6 permutations of these three objects taken all at a time. Similarly, sometimes we are interested in the arrangement of smaller number. Here I am having 3 objects, but suppose I am interested in the arrangement of 2 objects. Then we can list out that suppose I consider AB, and because order is important, BA is considered as different. Similarly, I can have BC and CB, AC and CA. So here also we can see that there are 6 arrangements of 3 objects taken 2 at a time. We are writing arrangement of 3 objects in which we are taking 2 objects at a time, taken 2 at a time. So this type of arrangement is called R permutation, or two permutation. Okay, remember these different words. Two permutation means arrangement of two objects out of three objects, or we can use the word that permutation of three objects taken two at a time. In other words, it is also known as two permutation. So two permutation means we are arranging two objects out of three objects, and here we find that there are six different arrangements of two objects taken at a time, and here order is important. So this is the meaning of permutation, that permutation is an ordered arrangement of n objects, and if you are considering r objects at a time, taken r at a time, then it is called an r permutation. R permutation means ordered arrangement of n objects taken r at a time. And we have ready-made formula to count the number of ordered arrangements or number of permutations, but before writing that formula, we can understand here also. Suppose we are interested in the number of arrangements of these three objects, that is n equal to 3, and taken 2 at a time. So we are interested in the arrangement of three objects which are A, B, C, taken 2 at a time. So we have two positions to decide, because we are writing two objects at a time, and repetitions are not allowed. So for first position, because we have three objects, for first position we have three possibilities. I can write either A, B or C for first position, and for second position, because repetition is not allowed, I cannot use the object which I have written here. So here I have to write 2. So that is 3 into 2 equal to 6. This is by product rule. We are using product rule here. We are considering the task of arranging two objects out of three objects as a combination of two tasks. Two tasks are assigning object to the first position and assigning another object to the second position. Because we have total three objects, there are three possibilities for first object, and because repetition is not allowed, whatever object is used here, that we cannot use here. That is 3 into 2, that is 6 here, and 6 we can write as 3 factorial. Similarly, here also we can decide that here we are arranging three objects at a time, so we can write here three positions, because we have to write down three objects in our arrangement, because it is arrangement of three objects. So for first position, three possibilities are there, and because repetition is not allowed, there are two possibilities for the second object, and for third object there is only one possibility. And here by product rule we have to multiply all this, and we can directly list out that there are 6 arrangements possible. So we can have another example also. Find the number of permutations of 6 objects, say A, B, C, D, E, F, taken 3 at a time. So we have to decide the number of permutations of 3 objects out of 6 objects, and because we are asked to find out the permutations, order is important, and we have 3 objects in the arrangement. So there are 3 positions, and for first position, because we have total 6 objects, there are 6 possibilities. We can write either A, B, C, D, E or F here. For second position, we cannot use the letter or object used here, so 5 possibilities are there. And for third position, we cannot use the letters used in the first and second position. So there are 4 positions here. So we have 6 into 5 into 4 number of permutations of 6 objects taken 3 at a time. So this is by product rule. So in this way, using product rule also we can count the number of permutations of given objects taken number of objects at a time. And we are having ready-made formula also, which we are familiar from our school level also. We know that if we have n objects and we are interested in the arrangement of r objects out of n objects, then that number is given by npr. Another notation is p of n comma r, and we have ready-made formula for this. It is given by n factorial divided by n minus r factorial, or we can write in this form also. If we simplify this, we can write n factorial as n into n minus 1 into n minus 2 into n minus r minus 1 into n minus r factorial. Because I have n minus r factorial in the denominator, I rewrite n factorial in this way. So you can see n minus r factorial will get cancelled, and we have n minus 1, n minus 2 and so on, n minus r minus 1. So either we can use this formula or we can use this formula to count the number of permutations of n objects taken r at a time, or to count the number of r permutations of n objects. You can see this is from product rule. Suppose I am interested in the arrangement of n objects taken r at a time. So I have to decide r positions 1, 2, 3 and so on up to say rth position. So for first position I have n possibilities. For second position I have n minus 1 possibilities because repetition is not allowed. For third position I will have n minus 2 positions. So you can see if I am writing second position, here I am writing n minus 1. Here for third position I am writing n minus 2, that is n minus 3 minus 1. This is n minus 2 minus 1. So for rth position I have to write n minus r minus 1. So this is how this formula is coming. It is coming from product rule. This is by product rule for counting. So all we have to remember is that the number of permutations of n objects taken r at a time. The number of permutations of n objects taken r at a time is denoted by npr and is given by n factorial divided by r minus r factorial, or we can write n minus 1, n minus 2, and last factor is n minus r minus 1 if we are arranging r objects. If we have r here, then we will go up to r minus 1. So remember this formula, that number of permutations of n objects taken r at a time is given by this, and here we assume that we are not allowing repetitions. So this is without repetitions. For permutations with repetitions we will discuss later in this lecture series. These are different notations for the number of permutations of n objects taken r at a time. And if we are considering arrangement of n objects taken all at a time, that is we have to count npn, and that turns out to be n factorial divided by n minus n factorial, that is n factorial divided by 0 factorial, which is n factorial. So there are n factorial permutations of n objects taken all at a time. So in this lecture we have discussed what is meaning of permutation, and as we discuss that permutation is nothing but any arrangement of a set of n objects in a given order. That is, order is important, and if we are arranging all the objects, then we write that taken all at a time. And if we are arranging r objects out of n objects, then we call it as r permutation or permutation of n objects taken r at a time. And the formula for counting the number of permutations is npr equal to n factorial divided by n minus r factorial. So this is all about this session. We will continue in this lecture series in upcoming lectures. Thanks for watching.